Thank you for coming. It's okay? Yes? Okay. Okay, so thank you for coming. And okay, in this presentation, I will start by introducing Spark and its ecosystem. And then I will see. Oh yes, it doesn't work. Enough. Yes. Sorry. Okay, maybe. Okay. So, in this presentation, like this? Yeah. No, it's not enough. Okay. Okay, so in this presentation, I will start by introducing Spark and its ecosystems. And following this, I will show you how to use Spark, Spark Streaming, and Spark SQL and MLlib to detect the language of tweets. And in the second part, Ilaya will explain how to integrate Spark with Spring XD. Okay. Sorry. Okay. It's okay. So my name is Ludwine Probst. I am a data engineer, and maybe you have guessed, I like drawing. And I'm deeply involved in two communities, Datasets France and Ladies Who Code. Maybe you know Datasets France? No? Okay. It is a group that connects women in IT. And in fact, we want to give more visibility to women developers and inspire role models. And we also organize coaching for women to increase the number of women speakers. And now, Ilaya.
Hi everyone, my name is Ilayaperumal Gopinathan, also known as Ilaya. I work for Spring team. I'm currently working with Spring XD and Spring Cloud Stream related projects. Over to Ludwine.
Okay. So, who is familiar with Spark? Yes. Okay. Do you use Spark? Yes. Maybe. Okay. So first, I just want to explain the motivation behind the project Apache Spark, and maybe just to recap, a few words about machine learning. So machine learning means that you will learn from example, experience, and if you just take a look at the diagram, so the first step is collect the data, not necessarily a lot of data, but well-chosen data. And step 2 is about creating a model. So to do this, you will use algorithm. And after that, step 3 is using this model, you will make some prediction. For example, recommender system or sentiment analysis, okay? But one important thing to remember is that most of machine learning algorithms are iterative. By nature, it's iterative. So that means that you need to reuse the data. And this is important for the rest of the presentation. So, and a few words about MapReduce and Hadoop. Past years, Hadoop and MapReduce were highly dominant for large-scale data processing. So if you look at the blue diagram, you can see the read and write process, okay? But it's very time-consuming, in particular if you want to iterate and reuse the data. And it's the same with HDFS. So it's suffer of overhead, I/O overhead. That's why Spark, okay, so, okay, we just saw that with MapReduce and Hadoop, it's not very efficient for iterative algorithm. And this is why Spark is born, actually. So the first goal was to provide a framework efficient for data reuse, okay? And, okay, it was just a joke, this slide. Maybe you, I don't know. It's actually, this is a joke. This is the definition of the limit. That's why it's push limits, okay? And yeah, because I love mathematics. So let's talk about Spark. Spark is a fast and general engine for large-scale data processing. It has been started as a research project at the University of Berkeley in 2009. And this is an open source project coded mainly in Scala. And today, Spark is maybe the most or one of the most active open source projects in big data. So the community is very, very active and release new version every 2 months. And the last version, 1.5, has been released the last week. So the main property in Spark is the processing in memory. So in this way, you can improve the performance. And that's why we used to say that Spark is faster than Hadoop. You can also use Spark on the top of Hadoop. We used to say that Spark is more flexible than Hadoop because Spark actually is not limited to the MapReduce pattern. So in fact, Spark provides a rich API, so you can process your data in a very flexible way and functional way. And one more thing is about the main abstraction in Spark. This is the RDD. RDD for Resilient Distributed Datasets. Actually, it represents your data. If you want to use Spark, you can do this with Java. I recommend to use Java 8 with the Lambda. And you can also use Spark with Scala, Python, and R. And in this language, you can use iterative shell. It's very useful for iterative testing and quick feedback. So now, okay, maybe more about RDD. So RDD is an immutable collection, distributed collection, partitioned across the node of the cluster, and you can operate on it in parallel. You can also control the persistence, so you can push your data in memory or on disk or both. And you can apply operation on your RDD. The two operations are action and transformation. A transformation actually creates another RDD because it is immutable. And a transformation is lazy. And an action, it returns a value after running a computation. So if you want to have a result, you need to apply an action after your transformation. And you can push your data into Spark in several ways. So you can use text files, sequence file, or any Hadoop input format like HDFS, HBase. And you can also use Google Cloud Storage or S3. And if you want to use Cassandra, it can be useful to use a special Spark Cassandra connector, which provides a specific RDD actually. But I will talk about this later. Okay. Now, when you create your Spark application, there is an entry point in Spark. This is a Spark context. The Spark context initialized your Spark job, and it connects to the cluster manager and pushes the code into the workers node, where it starts some tasks that run in parallel. And you can use different cluster managers. Today, you can use a standalone mode, including Spark. You can also use Mesos or Yarn. And before I show you a first example, this is a global view of how it works. So to the left, there is your data coming from external storage like HDFS or text files. And then you push your data into Spark, okay? And the first thing you are doing to do is to create an RDD, okay? So here the RDD is the boxes, the orange boxes, and the small boxes are the partition of the RDD. You can apply transformation on RDD, and it will create another RDD because this is immutable. And if you want to run the computation, you need to apply an action like count or first take, and it will be sent the partition across the nodes, okay? Just one more thing. Actually, each time you apply an operation on your RDD, it is registered in a graph. So if a partition is lost, it can be rebuilt automatically in using the graph. Okay, now this is the first example. So maybe you know this example. This is the word count. This is like the hello world for big data. So imagine you have a file with words, and you want to count how many times each word appears in this file. So the entry point is the Spark context. So here, at the beginning, you will create the Spark context with a Spark configuration. The Spark context will represent the connection to the Spark cluster. In the Spark configuration, you can specify the name of your application, but also the master. Here, okay. Here I decided to launch, to use the local mode. That's why there is a local. And the start means that I will use as much as core I have on my computer. And, sorry. And then I will load the data. So to load the data, I am using the text file function. It will create a RDD. And because, each word is separated by a space, I need to apply a flat map function to split the word and to create an RDD of words. So this is the last line of the code. Then, okay, I am using the MapReduce pattern to do this. So the first step is the mapper step, and actually I have the word in my RDD, and I want to attribute 1 to each word. So with the map to pair function in the first line, I will create couples with word and 1, okay? And after that, I want to reduce, I want to add all the 1. And to do this, I will use the reduce by key function provided by the Spark API. So, and yes, this is so the reducer step. And I will obtain couple with word and how many times this word appears. And at the end, if I want to persist the data in memory, I just need to apply the cache method. Now, to finish, okay, just an example. Maybe I would like to keep the word which appear more than 4 times. So to do this, there is a filter function in the Spark API. So I just need to write the condition in the filter function, and I will obtain the result. Okay. So, okay. Now this is a part about the Spark ecosystem with example on tweets. So actually, Spark includes standard component. There is Spark Streaming, Spark SQL, GraphX, and MLlib. And these components are built on Apache Spark and benefits of all the properties of Spark: distributed computation, speed, data, and memory. And the good news is that you can combine these frameworks together in the same application. So first, Spark Streaming. Okay. Spark Streaming, this is a component that allows stream processing of live data stream. Actually, Spark Streaming receives live input data streams from many sources like Kafka, Flume, Twitter, and it divides the live stream into batches. You can choose the window of the batch, and then each batch is processed by the Spark engine to generate the result in batch. And in Spark Streaming, you have an abstraction, the DStream for DStream. Okay, so DStream, and DStream represents a sequence of RDD. But I won't go into details because Ilaya will explain Spark Streaming. So, okay. And now I just want to show you how to use the Spark Streaming API. So here is a problem. So, okay. I work with a dataset of tweets, and the goal is to predict the language of the tweets. Okay. So in my example, I am going to use a Twitter streaming API, Twitter 4G, to collect live data streams. And you can find the code of my GitHub account if you want. And to do this, I am using Java 8 and Spark 131 because Spring XT doesn't support the last version of Spark. So, okay. So first, we need to connect to the Twitter streaming API. So it is pretty easy. So you just need to create your Twitter app and get your own credential. So consumer key, consumer secret, access token, and access token secret. And then you are in Spark. So once it is done, you have to initiate the Spark conf and Spark context, because this is an entry point. And because you want to use Spark streaming, you need to specify, you need to initiate a specific context. This is a Java streaming context, okay? And you also need to specify the duration, the interval of each batch. So here I decided to take 2 seconds for each batch, between each batch. And just at the end, you need to apply the start function if you want to start the computation. It won't work if you don't apply this function. And but I will make a demonstration after that. Okay. Once you have your Spark context, you want to retrieve the data, the live data stream. And to do this, you just have to use the createStream function provided by the Twitter 4G. Okay, so you can apply a filter or not, and it creates a DStream at the end. Finally, you can print the tweet using the print function. Yes, and just before the demo, this is how to save the data. So there is some save function provided by Spark. So here I decided to save the data in a local file as JSON. Okay, now the demo. So, wait. I had a problem with IntelliJ, so I need to run IntelliJ again. But if you want to, no, nothing. Okay, so so if you want to create a project with Spark, it is easy. You just have to add some dependencies on your. Here, this is my POM XML, but this is okay. This is pretty easy. You add the dependency for each component, okay? And then here is the code for Spark Streaming. So I just want. Okay, I just will run the code and show you. Okay, here I am. Okay, so here I am collecting data from everywhere. So here this is a tweet created at the text. Okay, and you have a lot of column. Okay, but now if I want, I can add a filter. So for example, here I want to see the tweet from the conference, Spring One. So I just need to add a filter there. And we will see the tweet, the live tweet. Okay, so maybe someone has tweet, I don't know, if you want to try. Okay, so here are some tweets with the filter Spring, Java, or Spark, or S2 or GX. Okay, so now back to the presentation. This is like this. Okay. Okay, now I would like to talk about Spark SQL and DataFrame. This is another component included in Spark, and Spark SQL is for structured data processing, and it provides a SQL-like interface. And in Spark SQL, the main abstraction is the DataFrames. In fact, DataFrame, it is a distributed collection of data organized as a columnar storage. It's equivalent to a table in a relational database or DataFrame in R or Python. And you can construct a DataFrame from different sources, such as JSON or table in Hive or external database or other RDD. And now this is the same example. So the beginning is quite similar to Spark Streaming. So you have your Spark configuration, your Spark context, and here you need to create a specific context, the SQL context, okay? This is the last line. And if you want to use Hive, there is a specific Hive context too. Then once you have created the Spark SQL Spark context, you can load the data. And here, my data were as JSON, so I just use a JSON method to load the data, and it creates a data frame, okay? But you can also use different type of file, and the API provide a lot of function to do this. You can print the data frame using show, the show function. And now, if you want to make some operation on your data frame, this is pretty easy. You have, for example, the select function. If you want to see all language using in the selected if you want to see the language used, you can apply a select with the colon lang for language. This is the first line. And you also can count how many tweets you have by language. And to do this, you can use a group by function, for example. And the last part is about filter, because you also have filter methods. So it's very flexible and easy, I think. But there is another way to apply operation on the data frame. You can also register the data frame as table. So to do this, you can use a function register term table. This is the first line. And then you can apply directly SQL queries on the data frame. So this is another way to make operation on data frame. I won't make a demonstration about this part because Ilaya will. Yes, okay. And now this is MLlib. So MLlib is a standard component of Spark providing machine learning algorithm and other tools on top of Spark. And today there is two packages. One package, MLlib, which built on the top of RDD, and the other one built on DataFrames. And actually it seems that in the next month the Spark team will focus on the second one. Yes. And of course, MLlib contains all common algorithms for regression, classification, reduction, clustering, and so on. And it's becoming fairly comparable to other popular machine learning library like MAUT. I don't know if you know MAUT, but there is a lot of main algorithm in MLlib today. And you can also find other tools like function to extract feature and transformation, and also basic statistic and optimization. Now this is the example. So in this part, I will use the K-means algorithm to detect the language of the tweets. And actually, I won't use all the tweets because it's not an easy issue. So I just will collect tweets in English, Spanish, and Japanese, just for the demonstration. Maybe you know already K-means algorithms. This is a popular algorithm for cluster analysis, and actually it aims to partition the observation into different cluster key. Okay, and so yes, and so to do this, this is the same as. Okay, and so we want to detect the language of tweets, where each language will represent a different cluster. So I will have 3 clusters. I need to load the data. So this is the code to retrieve the data. So Spark Spark configuration, Spark context, and SQL context, because I will use a data frame. And then, because I won't select only the tweet in English, Spanish, and Japanese, I just run a SQL query on my DataFrame. And here, this is a code. Actually, I just need to keep the content of the tweet to build the feature to train my model. So here, this is the operation to transform the data frame into RDD using the Java RDD function. And then I only use a map function to keep the content, to extract the content. Okay, this is just to say that when you have data, when you want to extract feature to build the model, you also need to clean the data. To keep it easier, I just remove some special character like hashtag or HTTP request, but it's not enough actually, but it was just to show you. And if you are interested in this problem, there is a nice GitHub account, Shuyo, about language detection. The link is on the slide. And okay, now, okay, this is the extraction of the feature using n-gram. To build the feature, I decided to take the content of the tweet and to take 2 characters per 2 characters. And then I have applied the hashing function using the Spark MLlib API. And in this way, I will obtain a RDD of vector. This is my feature. And now, once I have these features, I can apply the K-means algorithm. So in my case, I have 3 clusters. I have chosen 20 iterations. And I just need to use MLlib API with K-means and train the model. And okay, the code then is available from Spark 1.4. You can save the model. It's very useful to make prediction then. Okay. I will make a small, quick demo again. And yes. Okay. It should be quick because there is only 3 languages. So you can see the bigram actually here. And okay, so bigram, this is like this. And then I just take 10 tweets. For example, this tweet is in the cluster 0. What? There is some funny stuff. Oh, sorry, but I don't know. Okay. Okay, I don't know why, but okay. Sorry about that. Okay, so English seems to be in the cluster 0. Spanish seems to be in the cluster 1. Okay, cluster 1, cluster okay, English cluster 2. Japanese cluster 2. So okay, everything is fine. Okay, So it's okay. Okay, I don't know why, but okay. So, okay. So, this one. Okay. Okay. Before I conclude the part, I just want to talk about some other interesting projects. The first one is GraphX. This is a Spark API for graph and graph parallel computation. So it includes a collection of graph algorithms. You also have Spark R. R is a very popular statistic programming language used for data processing and machine learning tasks. But R can only process data on a single node. That's why Spark R is very interesting, because Spark R provides R frontend to Apache Spark, and you can run your R code on a cluster with Spark R, okay? And finally, the Spark Cassandra connector. It lets you expose Cassandra tables as Spark RDD. So you can persist Spark RDD into Cassandra tables, and yeah. Just a few words about Spark 1.5. Actually, the team has worked on the performance, the team has working on improving the Spark performance, and with the project Tungsten. There is some post on the Databricks blogs if you want to have more information. They also add some new machine learning algorithms, and especially some stuff about R. And there is some news about Spark Streaming too. So, okay, I will conclude now. So, to resume, Spark is an engine for large-scale data processing. It is very fast, faster than Hadoop in many situations, especially if you want to reuse the data. Spark has a rich ecosystem with MLlib, Spark Streaming, or Spark SQL DataFrame. And this is a very active open source project with a lot of contributors, so it evolves very fast. So now this is Ilaya talk, and yeah, I let you.
Thank you, Ludwine, for the introduction to the Spark ecosystem. So I would like to go into the internals of Spark, especially in Spark Streaming, and then we'll see how SpringXT leverages the benefits of Spark. Talk about the Spark Streaming. Important key parameter is the batch duration. It's all about creating a distributed data sets in your executor cluster. For Spark, all it needs is a target cluster, which could be Yarn or MesoS or any a Spark standalone cluster, which is not recommended for production, or a local JVM you would run for development environment. But when you receive streams of events, like when you receive some external, when you receive events from external data source, it's for stream processing, you wanted to convert them and make them available in the Spark cluster so that you can run some parallelized operation on it. That's the key of doing Spark streaming on the Spark data engine. All we need to do is convert the incoming data and make them available as in the form of RDD. So when we talk about RDD is distributed. It's going to be distributed across multiple executor nodes. in the Spark cluster, and it's replicated. So you will have multiple copies of it. So in case one node goes down, you will have the same data available in another node. And it is partitioned. If you talk about RDD itself is partitioned. It is location aware. So when a Spark driver, which is running on your local, typically a Spark driver runs on your client application, and it will trigger or it will submit tasks in terms of stages into the Spark cluster. So we'll see how Spark streaming works in terms of submitting tasks in Spark cluster when we receive data. So Ludwine talked about DStreams, discretized streams. It's the incoming data would get converted into block RDDs. So we'll see what block RDD is. It's about, so there is a batch interval you define. When you specify the Spark streaming context, you will define the batch duration for your application. That is the duration in which the Spark driver would submit the task against the data sets in the cluster. So for a batch interval, you will expect an RDD available in the Spark cluster. So you will have a distributed, replicated, partitioned RDD, which is called as a block RDD, available inside the Spark cluster. So now the Spark driver will submit the task against those partitions. So those partitions are locality aware in the Spark cluster. So the Spark driver knows where exactly my data is in. And then it also forms a lineage of the stages of all the RDD computations. So when you develop an application for Spark, you'll specify multiple higher order functions. You know what to expect. And then you will specify one map, a flat map, and you will have higher order functions defined. All those would be converted into RDD operations. So a Spark driver will form a direct acyclic graph. There is a scheduler that runs on the Spark driver. It's going to develop a DAG and then submit the tasks on an RDD, and it knows how to execute them. So it knows all the information or the locality information about those data sets, and it knows where to send the executed code to run on the Spark cluster. So how do we create a DStream? So in a typical Spark application, you will have your data set available. You create, let's say you have your data available in Hadoop file system, and then you will say, just point to load my Hadoop file system and run this RDD operations, whatever the word count example you will run. But for a DStream, your data is not there. You need to receive data from somewhere, right? So you will have some data sources. It could be sensor data, Twitter streams, or even the file systems. So you need to create a data stream, a discretized stream, in order to submit the tasks against the incoming data. So it's all about creating DStream. Now we'll see how to create a DStream. A DStream can be created by simply loading the file. If you have a data available in the HDFS, then you will just load the file, and that file will be loaded at the Spark driver level, and now it knows where the file is located on the HDFS, and then it will submit the task, and that's simple. Now let's talk about a stream where you will receive data from external data sources. For that, it requires a receiver input DStream. So you need to have a receiver available to receive the incoming data, and then once the receiver receives the data, and you need to form the blocks of data in the name of RDD, so that the driver will submit the tasks against those RDD. And this is what we call parallelized operation. And that's the exact benefit we will get when we run the Spark application on a Spark engine. So there is one other DStream, which is like if you run an operation on an existing DStream, it will create another DStream. So now the Spark driver will know the output DStream's locality, and then any subsequent task will be submitted against that location. So this is the advantage of locality-aware processing, and Spark Engine is all about it. Let's talk about receiver. So receiver requires to be running all the way when the Spark streaming is running. So because we need to receive some data, it's a sequence of events coming in. And then there is a batch duration. We know that the batch duration is set at the Spark streaming context level. So, and then there is a block interval that is by default set to 200 milliseconds. We can control that block interval. And in Spark streaming, block generator runs on a block interval. So it's going to generate a block every block interval. So let's say a receiver receives data, and then block generator does two operations. One is get the data that the receiver receives, generates a block out of it, push the data into the block manager. So now the block manager gets a block, and now Spark driver has a job generator that submits a task against those generated blocks. And then a job generator now will create a block RDD. And this is similar to any other RDD that a Spark application would have. Now, a Spark driver will submit the task against those block RDD. And so you will get a block RDD for each batch duration you configured. So I wanted to make a simple example so that it's clear in Spark streaming case. So let's assume that we receive this data, a sequence of data, 10, 20, 30, 40. So that's a sequence of data. And then for a block interval, we receive 10, 20 for the first block interval period, and then for the second block, block 2, block 3. And let's say for the first batch interval, we receive the block 1. And the second batch interval, we receive 2 blocks. And these 2 blocks are the partitioned blocks. So you'll see block 2 is located somewhere, block 3 is located somewhere. But it will form an RDD that is a block RDD for the interval batch 2. And when we run any operations against RDD, the Spark driver will submit a task against each batch, each block RDD. So there will be multiple tasks against each partitions. So in case of first block, you will see 1 task run against a partition. In case of second batch, you will see 2 tasks for each partition. So the block ID has the locality information on the Spark cluster. So receiver is classified based on its reliability. When the receiver receives data from the external data source, it needs to acknowledge the data source that it received the data and it's stored in the storage layer. And if it doesn't acknowledge, then in case of any failure on the receiver node, then the data is lost. So based on that, Spark streaming classifies a receiver as a reliable or unreliable receiver. And it's important to note that since a block RDD is generated on each batch duration, you need to make sure that the average batch processing time should be less than the batch duration. Otherwise, the upcoming batches would wait for the previous batch job to finish, because each job is submitted against the job that is created on each batch duration. So we know that the Spark submits tasks on the data that is on the executed node that is very affinity, that is closer to the data. And so that's what the block RDD will have. Block RDD will have the information about the location of the data. So there are some of the error scenarios in Spark streaming. What happens if the Spark driver itself failed? In case of driver failure, the driver has the DAG information. It knows how to form in case of failure. The lineage, so that in case of failure, it can form from the recently checkpointed information. If you don't do the checkpoint, then it has to start from the beginning. And for a longer lineage, if you have many RDD operations defined in your Spark application, then you would go for checkpointing, so that every time you have an RDD created, it will checkpoint. And then in case of failure, it will come from the previous. So it doesn't have to recompute the lineage from the beginning. And executed node failure has 2 things. One is the receiver failure. If the receiver itself failed, then as we talked about, if the reliable receiver is in place, then you will know that the message was acknowledged after it was received. Otherwise, you will have a data loss. In case of tasks failure, since the data is replicated, since an RDD itself is replicated and partitioned, the same task, the driver is aware of execute a failure, and it will execute the same task on a different location where that data is replicated, because the block RDD has all the information about the location. So for those of you who haven't got a chance to explore Spring XD, I would like to give a brief introduction of Spring XD, and then we will see how Spring XD uses Spark. Spring XD is a platform or a runtime for developing and deploying your data-driven applications. It's not a framework like any other Spring framework. It's a runtime. So you would use for developing and deploying your applications. So you would use it for data ingestion. So Spring XD provides out-of-the-box sources that connects to typical enterprise or commonly used data sources. And so you can directly configure the source and connect to the external source, make the data available in your source, and then do some transformations on that data. And there are also commonly available sinks, for example, HDFS or MongoDB or Cassandra. So you will write the data into the sinks. So at the same time, you will also do parallel analytics. There is a model called tapping. So when you do a stream processing, you will also tap into multiple endpoints where there is a producer of a message. Typically, you would tap into a source or a processor where there is a message output. And the same data, as it gets ingested, you will do parallel analysis of the data. So you can create n number of streams that can be, that can tap into an existing mainstream. To summarize, you have a mainstream. At the same time, you have parallel streams that does the different applications. When I do a demo, I will show what does that mean. And also for any offline data records processing, you can do a batch processing. And these are all built on top of Spring integration and Spring Batch, which has been in the market for more than 10 years. So how Spring XD uses Spark. So you can use, so if you are a Spark user and if you want to develop your Spark application, you can use a Spark application as a processor level where it does the parallel computation. Let's say you're doing some data intensive operation where you would want to distribute your incoming data and do parallel operations, and then you want to pass the data output to somewhere else to write the data into HDFS or MongoDB. Then in that case, you would use Spark application as a processor, which is an XD processor. And so it will execute the data computation on the Spark cluster and make the data available on the subsequent XD module, so that your mainstream would be a simple XD stream. And if you yeah, sure.
Does that mean that you basically ping pong with Spark? Because you have two runtimes.
Yeah. So
You just turn it over and get the result that you're ping ponging between two runtimes.
Yeah. So typically, the Spark cluster would be Yarn or the Mesos. So if we are running our target runtime on Yarn, then it would be easier for you to move your executor on Spark and get the work done, because you wanted to parallelize your workload using Spark engine. So this way, Spring XD leverages the benefit of Spark, and then it comes back to Spring XD for further processing of the stream, because Spring XD provides more than what a parallel computation does. I mean, because we still wanted to get the benefit out of Spark, but at the same time, we wanted to showcase how powerful the Spring XD is if you use Spark inside Spring XD. So the question was, do you want to shift your executor out of your Spring XD cluster to Spark and then come back? It's actually, if you're running on the same environment, it is like running another module where you have another operation running on a different JVM. You can also run a Spark application as a batch job. Let's say you are running an MLlib algorithm. You're not worried about incoming sequence data, and you are worried about the data that is already there in HDFS file system. You can run reiterative algorithms on Spark. So you can, but by running it, you will get some out-of-the-box capabilities of Spring XD. If you have used Spring XD, you would know what I mean. So you will have orchestration of batch processing with running a Spark application inside Spring XT. Okay, now I'm going to go over the advantages of running Spark using Spring XT. We wanted to simplify the development experience like any other Spring projects. We wanted to move all the boilerplate things out of developers. So what we provide is a simple interface, or for most of the Spark developers, if they are comfortable with Scala, then we still wanted to support it. So you can write your Scala module, and then you just need to extend this trait that we have in Spring XT and make the module available, and it would just work. It's all JVM. And if you are Java, then you would just implement this specific interface. I will show that interface soon. You will need to implement this interface, and you are good. You don't have to set up the Spark streaming context and everything. All you need to do is to provide a configuration property for a Spark streaming to get started. A configuration properties like batch duration, your Spark cluster information. And so handling your launching of Spark streaming job and lifecycle management is handled by Spring XT. And let's say if you have used to Spark, then you will see you would have experienced lifecycle issues in terms of whether when to stop an application, whether it is okay to stop, those kind of things. And with Spring XT, it is considered as a XD module, and then you will have a control on the lifecycle model of a stream. So a Spark module would be considered as like any other Spring XT module. So you will get all the benefits of Spring XT out of the box. The main scenario where you would be really interested in using Spark in Spring XT is that, let's say you have a scenario where you wanted to ingest the data from some near real-time data processing, and then you want to ingest the data and do a quick filter and then write them into a big data store like Hadoop or MongoDB or whatever based on your use case. And then you wanted to do some parallel analysis on the same data. So we were discussing about TAP model and Spring XD, which lets you perform multiple analysis on the same data as the data goes through. So you will specify your mainstream in Spring XD, and then you will tap into the mainstream and create feed that tapped data into your Spark module. And then you will also create n number of streams to use the same data, and you will write, you will perform multiple parallel analysis of the same data and write to various data stores. So you will do all these parallel analysis with the Spring XT model, which you won't be able to do with a plain Spark application. And also we recommend you choose the data computation based on your need. If you really wanted to distribute your data sets, the incoming streaming data sets, if you really wanted to parallelize the computation, then go with Spark. Otherwise, for a simple transformation like filtering, just a payload conversion, you don't really go for Spark for it, right? So we recommend using any iterative processor if you really want to parallelize. A typical example would be the example that Ludwine showed as DataFrame. You really wanted to load multiple data in parallel and then do some performance. That's the scenario where you really would go with the Spark in Spring XT module. Otherwise, Spring XT's processor itself would be enough for you to do the stream processing. It doesn't make sense to go with Spark in all the use cases. I think it's important to choose your use, to use Spark based on your use case. And some more advantages. The receiver that we have in Spring XT is a reliable by default. It's a reliable receiver. So it always acknowledges the messages after it stores in a Spark cluster, Spark storage level. So when you configure your Spark application, you would say which storage layer you would use, right? So you would use a memory if you don't care about distributed memory, distributed data replication, or you would use memory and disk, or you would even use tachyon. So in that case, the reliable receiver would make sure the data is stored, and then it will acknowledge the receiver. And the receiver that we have is simply connecting to the message bus that Spring XD has. The message bus is a Rabbit or MQ or RabbitMQ or Kafka. So you can directly connect to Kafka. This is more akin to what Spark recently has as a direct Kafka connector that doesn't need to have a write-ahead log implementation. So this is more similar to what we have. So that removes the importance of having a write-ahead log to avoid data loss in case of receiver failure. So we have a reliable receiver out of the box. And so if you want, you might have seen some use cases where there will be multiple receivers running inside your Spark streaming applications, and then you would union them. Spring XD doesn't use multiple receivers because by default it supports a partitioning at the message bus level. So you have you distribute your load at the partitioning logic when you define at the stream. So I will show you a diagram where you will see a partitioned stream. Let me see if so this is that the partitioning that I'm referring to. For us, when you define a stream, you will know which, let's say you are using Kafka, for example, as a message bus. You will know which partition's topic my message would go to. And your receiver will just look at that exact topic so that you don't have to configure multiple receivers for a simple module. So each module would have a single receiver and it would connect to the corresponding message bus queue or a topic. And then it will proceed with the parallelized computation on that partitioned data. So the stream itself is handling the partitioning. We have extensive support for lifecycle management. Like a typical XD module, you would deploy, undeploy, destroy. These are all handled smoothly when you run your Spark inside your Spring XD application. So typically what would happen is when you create a Spark application, you would create a Spark module, and that module would be deployed inside a XD container. And the XD container is the place where you would run your driver. That's the client application for your Spark application. And then now, since you have already configured the cluster that it needs to talk to, it will talk to the corresponding cluster to distribute your tasks against the data sets. And so in case of driver failure, if the node itself failed where the module is running, then Spring XD knows to restart that container and redeploys that module again. So you will get this fault tolerance out of the box. This is similar to any other Spring XD module fault tolerance capability. Yeah, so we discussed about this. And this is the marker interface that any Spark module developer would implement. And the above one is the trait that you would extend if you are writing in Scala. The below one is the processor interface that you would have to implement if you're using Java. We recommend using Java 8 as Ludwine noted. It's easier and crisper if you're running higher order functions. And now let me switch for a demo. I'm going to start Spring XD in a distributed mode, and I'm going to deploy a Spark module. So let me start container. I'll increase the font 1 second. So this is a XD container, and I've also started XD admin. I have a word count sample. It's in the Spring XD samples repository if you are interested to try out. So this is the processor we have. As you see, all it expects is the Java DStream. if you return so the DStream is what is received from the receiver. In this case, it's a receiver. A receiver is a message bus receiver that is internal to Spring XT itself. So you don't have to worry about receiver implementation at all. All you need to do is connect to the source module that receives data from various data sources that Spring XT supports. I'll write a demo stream in a bit. But this is the implementation. So this is the exact copy of what the Spark documentation has as a Spark word count. So this is more like a copy paste your existing Spark computation logic into Spring XT module. You just implement this process method and then provide a higher order functions that you want to compute. And like I said, these are all the flat map and then the map to pair are all the RDD operations that the Spark driver would look for. And then these are all the lineages it would compute and then submit the tasks. So you will have intermediate DStreams, right? So this is the first input DStream that is created out of the reliable receiver, which is the message bus receiver. Once the data is in there, you're going to compute another DStream, which is a flat map of the incoming data, and then one more DStream that has the word count result. And like I said, this is just a copy of the Spark example. And the advantage here is you can control the Spark configuration from the module. So you will supply the Spark configuration parameters via this module itself by implementing this, by using this annotation. You will still simply need to supply these properties. So you would say, so currently I'm running on a Spark standalone cluster. So if you want to run it on local mode, you can just uncomment this. You can say, all the Spark configuration parameters here. So yeah, I forgot to show that I'm running a Spark standalone cluster here with 4 core, so that I would, if I run locally, then I would at least get 1 core for the receiver. So if you're running on development experience, so if you're running in a development environment, make sure that you allocate enough core because receiver itself would occupy a single core. Okay, so now this is the word count example, and I'm going to deploy this module into XT. So I just started the admin and container. So I'm going to create a word count stream. So the word count input, I'm going to. So this is the. So I have a file, simple text file. Book chapter. So I just wanted to read the data from here. Think of it as the input to your Spark application, but you are creating a module that connects to the external system, and you can replace this with Twitter. You can replace this with Kafka, that reads data from it, or you can replace this with MQTT. So this is the powerful capability of Spring XT, right? You connect to any available data source and make the data available for your Spark engine to process. You don't have to write any receiver code. You don't have to write the data ingestion part. That's not Spark's concern. Spark is concerned about data computation by parallelly distributing your data. And it needs to be done that way only. You don't want to write your ingestion code inside the Spark application. So as a simple demo, I am creating a file. I specify the directory, that is temp files. And then, so this will list all the available module, and I have pushed this word count that I just showed, and then display it in the log. And typically you would just say HDFS or MongoDB, and these are available out of the box in Spring XT. You don't have to write any code here. You just need to provide the configuration parameters. So for the first demo, I'm writing this to a log so that you will get the sense of what's going on. So I'm deploying, and by default, I'm pointing to the Spark standalone cluster that is running locally. I just showed this one. So my tasks would be submitted here on this worker. So we'll see how that. Let's see. So now it's going to get deployed into a Spark cluster. Okay, so it just started processing the canary. That's not a good sign. Let me see. Okay, yeah. So that brings up a good point. Actually, I need to make sure that the correct data type is passed to Spark, because the Spark application expects a plain text string. Here we read raw content from the file, and it's just a byte that is sent. So I would destroy the stream, and then the same stream I would specify output type text plain. This is all you need to do to make the conversion, the module type. I mean the type conversion of the data. So now the word count would receive a plain text string, because we were processing. We assumed that we received the plain text string, right? Let's see if that works. Okay. Okay, so now we got the list and results of the count results for each word in that text. And I want to show you what's going on in the cluster. So this is still running, and if I put a new file in that files directory, it will start processing again, because the stream is still on. So if you see, these are the actual the tasks that are submitted by the Spark driver from the container to the Spark cluster. So it shifts the workload to the Spark cluster on the Spark data engine, and it computes everything in parallel, and then sends a result back to the log module. It's not the console of the container. It's the console that the log module gets. So it's you can think of it as another module. So you can think of it as a HTFS writing the data, the result data, into a Hadoop file system. The next example, the next demo, I will show HTFS. So I'm destroying the stream. So I don't have any other streams. So now I'm going to do a scenario that I was explaining a bit before about reading real-time data and then ingesting the data. At the same time, you want to do some parallel processing. So I'm going to create a Twitter example where I would read the Twitter sample from the Twitter API, and then that reads the data and just simply put it into HTFS as my raw file data. And at the same time, I would do some parallel analysis of the same data. So I'm going to create a stream, tweets. Oh, I forgot to show. So when we destroy the stream, it should have removed the see that is removed. So that the lifecycle management. So if you undeploy, it would remove it as well. So that is handled by Spring XD container automatically. That is treated as any other module. Okay, so I'm creating a tweet stream, Twitter stream, and I have already configured my API keys, so that's fine. So by default, this Twitter stream sends JSON output, so I don't have to specify output type here, and I'm writing the data to Hadoop file system with the rollover. I just want to showcase this, so I'm restricting the lower size for this. Default is 1 MB. I'm not deploying the stream yet. Let it be there. So this is the stream, and then I'm going to create another stream that does the parallel analysis. Let's do the data frame example that Ludwine pointed out. So I'm opening the DStream. So this is this typical implementation of a Spark module. So I would implement a processor interface, and that expects Java DStream as input, and so this is the DStream string, the JSON string. And then once I receive the data, I convert, so this is the same exact copy from the Spark example for the data frame. Or in fact, I copied from Ludwine's example. So this is what the development experience. So whatever the code that you write on a typical standalone Spark application, we wanted to make sure that the same application can be run on Spring XT, but the benefit that you get out of it is more, as you can witness. So I just copy the same code, and this is a processor, so it's going to return some data. So I wanted to show that to the log. We'll see that here. Stream create. The frame output. So I'm going to create a tab on the tweets stream. That's the name of the stream here. So I'm going to tap here. As I said, the tab can be at the output of any module that produces output. So a tab can be at the processor level, or it can be at the source output. So that is the output, and DFrame. That's the module that we just seen, and then deploy. Or in fact, I can just, since I have show here, I call the show result.show. It's going to display it at the driver. So the driver is running on the container, so we'll see that. So you don't have to have multiple displays. One thing that I missed to point out here is that based on the return value, a module will be considered a processor or a sink. So here it returns a null, so this is a sink module. This is not a processor module. So that's one of the reasons why I just simply show. So it receives the data, it receives the tweeted data here, and does a data frame operation. It computes, it creates a tweets table, and it performs the data frame SQL. It's a Spark Streaming plus SQL, Spark SQL, and out of that table, it shows the result, language, and then the count of each tweet. So now I'm deploying this tapped stream, but remember I haven't deployed the main stream yet, but the tapped stream is deployed, and it's here, and it should be, yeah, it's just started displaying the empty result because it doesn't counted any incoming data yet, because we haven't started the main stream. So now I'm going to start a main stream, which is Twitter. So I'm saying deploy my main stream. As you can see, the main stream gets the Twitter data and then writes the data into a Hadoop file system. You can have a simple filter logic here that removes a specific language or whatever, the raw filtering. That doesn't have to go through Spark, right? And all the data computation, the real computation is here. And you can create more and more parallel streams out of the same data, right? You can create another DFrame that does a different logic, that does the parallel computation, right? And that's the benefit of Spring XT here. You can do multiple analysis on the same data, right? Now I'm going to deploy this Twitter stream. Now the Twitter stream started coming in. Now we are going to get some results out of it. As you can see, for every batch duration, you will get the result. And I hope that that makes your understanding better in terms of how Spring XT leverages Spark's capability. I'm getting back to the slides. So what's coming? So we are, as you have witnessed, we have been actively working on Spring Cloud Stream and Spring Cloud Data Flow projects. So the next step for us is to have Spark as a data engine for a Spring Cloud Stream module with a configurable annotation of a module that would qualify to be run on a Spark data engine. So all you have to do is to develop a Spring Boot-based application with an annotation that denotes that this application is a Spark engine-enabled application, and that would be shifted to the Spark engine, get the result out of it. That's the next step for us. And so we'll also have a Spring Cloud Stream task modules where you would run a batch job module, and the same thing would applicable for the task. So where you would be running a task, for example, an MLlib job, right? So you will run a task which is a Spark MLlib algorithm on a Spark engine, but it will run against an offline data on an already stored Hadoop file system data. Opposite to what Spark streaming does, instead of processing the live incoming data, it would process against the data that is already stored. So we wanted to support both because both have a valid use cases. These are some of the useful resources that includes Ludwine's GitHub repository and other Spring XT related repositories. So feel free to give us some feedback, and we would be happy to address your concerns and feedbacks. Thank you very much for coming here, and I hope you found this time useful. And I forgot to ask, feel free to ask your questions. Yeah.
So I'm just wondering, using Spring XT, how does my typical, for example, Spark job change? I write it in Scala, I have a Spark context, and I point it using, for example, text file like HTF. How does my typical Spark job change?
The question is, if you are writing a Spark application and what change you would expect when you run the same thing in the Spring XT, and you won't experience any change because it's all you need to do is to implement the interfaces, and you would get the handle on the Spark streaming context at that level.
Okay. Yeah. How does Spring XT know about the Spark context? I instantiated and configured about it. How does it know where I point it to the HDFS cluster?
Yeah. So when you deploy the module. So we have a Spark Streaming plugin. When the module gets deployed, that plugin configures the Spark Streaming context based on the configuration that you pass in.
Okay, based on that.
Yeah.
Somewhere a Spark context is created.
Yeah. The Spark context is created when the module gets deployed. Yeah. And then it will also be available for you inside the module code. So you can say Java input DStream that get context. So you can get the context handle if you want to operate inside. If you see the DataFrame example, that's what I have. I got a handle on the DataFrame.
Okay.
Yeah.
And about a half an hour ago, I found out, were you managing multiple Spark jobs with Spring XT, or was that one single Spark job?
Yeah, about if you have used Spark, then you have about the constraint we have, right? So, but the way we alleviate that problem, I'm sorry, I forgot to repeat the question. The question is, how do you run multiple Spark jobs? Because Spark has a constraint, so JVM cannot have multiple Spark contexts, Spark streaming contexts. So it's simple. We have multiple containers, so each container would get its own job. So it's you just need to push your module into respective containers. The Spring XT can have as many number of containers you want. Every container is its own JVM, and that is free to have its own Spark streaming context. Exactly. So we have a validity check as well. So if a Spark streaming context is established on an existing container, we won't classify that container for any further deployment of Spark module.
And the container is instantiated its own JVM, right?
Yeah, it's for Spring XT. It's about starting a new JVM. A container is just a JVM that's running on a host. It can, but there could not be any conflicting dependencies. We have isolation levels.
Thank you.
Yeah, sure. Thank you. Have a nice evening.